Hello and welcome to this feature spotlight on version control within Emulate 3D. I'm Andrew Diebel, the product manager for Emulate 3D, and I'm delighted to show our new integrated GIT version control that comes with Emulate 3D 2025. It's probably easiest to show this in action so you can get an idea of how this is going to help you build models, catalogs, and scripts. And we're going to apply this to a small model, which is going to be a Singulator component. This has been built out of standard conveyors, load creators, and deflectors from the catalogs, and it's going to take product in kind of a jumbled arrangement from one side, and we should end up with nicely aligned boxes, leaving this conveyor on the other side. This is making use of Emulate 3D's lovely physics engines, and it's also using some nice lighting to show off the new Unreal rendering engine, which is also available with Emulate 3D 2025. So why would we apply version control to this model, and what is GIT? GIT is a free and open source distributed version control system that's going to track versions of files for us. It's going to record changes to those files over time so that we can recall specific versions later on. So you can kind of think of this as, rather than saving a model, we're going to create checkpoints, which we can revisit, and that we're going to write a message to say exactly what we did. GIT's going to track who made what changes and when. This is going to be useful, first and foremost, because it's going to be a much better way for us to back up our work. We can jump back to these checkpoints if some change we made to our model or design didn't quite work out. It's going to give us an audit trail as well, so we can understand exactly what we changed. It's really useful if we're doing some controls testing and we maybe tweak a sensor position and we want to go and make sure that this is recorded so that we know that we need to make this change in the field. Version control is going to let us collaborate on projects as well, because we can see what our colleagues have done to a model, and we have advanced tools like branching and merging that's going to allow us to simultaneously work on the same models, catalogs, and scripts. So we've got a model here that we've started off with, which is a base Singulator, and I think that we need to make some changes here because this is getting blocked. If we zoom in detail, we can see that potentially this return conveyor is not quite wide enough for the parcels for the boxes that we're sorting, and we get clogged up. We can see this if we enable the physics view just here, that we're stuck. So let's go and add this model to version control and see if we can experiment and fix the problem just here. Under the File menu, you can see a new version control option alongside the expected save options. We can choose to version control not only our model, but any of our open catalogs as well. First step we need to take is to enable version control for our model, which is going to save our model in a slightly different format called Demo3DX. This is a folder with lots of subfiles that lets us split up, say, a material property from a script, making it easier to understand exactly what has changed in our model itself. Let's enable version control. Let's save out our Demo3DX file. And let's put in a commit message. This is going to be added to our history, and it's going to help us work out what has changed in that commit. This is our audit trail that helps us understand what we've done to the model. So let's say adding the Singulator to version control. In the commit history, I can now see an author, a date and time, and a message associated with that commit. Let's go back to the model and make some changes. The problem we saw was that the Singulator got jammed because our returning conveyor was not wide enough. So let's go into select mode. Let's click the first section of conveyor. Let's hold down Shift and click the last section of conveyor to select all the conveyor between those two sections. And let's change their width from 0.6 of a meter to 1 meter. We'll want to reposition these gently. I'm just going to drag this to make sure it snaps in the right location. And then, out of laziness, let's take this deflector and let's just rotate it so it's roughly aligned and see if this behaves a little bit better. So let's run our model at fast forward and see if this fixes our jamming problem. You can see that this is much better behavior. We're not seeing our boxes hitting each other and getting snagged up. But we are seeing a problem on the recirculation. This deflector angle is a little bit too steep in order to gently bring these boxes back onto the forward conveyor. Well, this is better. Let's save this as a checkpoint. We're going to go and open up our version control window. And rather go into the file menu, let's open up the dedicated version control window. I personally like to dock it here at the bottom so I can quickly make commits as I'm working on a model. If we save our model, we can see the changes that we have made since our last commit. Note here that saving is different to committing. We can save our model as many times as we want whilst we're building things, but when we make a commit, this is going to be like a checkpoint that we can go back to in the future. We can see the changes we've made since our last commit, and there's been some changes here to our model. So if I double left click on this here, it's going to bring up a change log, and we can see that for a number of conveyors, we've changed the bed width from 0.6 to 1, and we've slightly tweaked their position. And this has been done for all of the conveyors and that deflector which we moved as well. Okay, I'm happy with these changes. Let's hit commit. And let's type in another message. Made the returning conveyor wider to prevent blockages. You can see now in the commit history we have two entries. We have our first commit and our second commit. Now at any point in time we can look at a previous commit and we can switch to this. And this is going to take us to that previous checkpoint. So here we were with the narrow returning conveyor, and then if we return to our current most recent commit, we see our wider conveyor just here. Now switching will let us peek at previous versions of our model, but if we wanted to make that more permanent and undo changes, we do also have the option to revert. For those who are familiar with Git, we also support separate branches, and you can switch between those branches, and this allows you to experiment, try some things out with a model, and then when you're happy, merge those changes in and make it more permanent. Let's go fix that blockage. Let's change this deflector. We're going to make our deflector here longer. I'm going to change it to be 2.2 meters long, so it's a shallower angle. Let's also make it wider. Let's change it to be 1.05 meters. And then let's use the snap tool in order to perfectly align it. I'm going to choose this corner. I'm going to hold the Alt key and I'm going to snap it to this location. Let's run our model again. We can see that this is performing much better without any jams. Now we could also use Emulate 3D 2025 features like the test runner to automate this testing process, to automatically run the model when we've made changes and to see if the system blocks up or if it successfully manages to singulate loads. But to hear more about this, you'll need to watch another feature spotlight video. Let's make this save and commit in one go with a log to say that we changed the deflector angle. We can see that the commit history is updated and we have multiple checkpoints that we can revert to during the course of the evolution of this model. Now what's actually happening behind the scenes here for people who are familiar with Git? We've made a local repository. We have then made commits to our local repository. And we now have the ability, if we wanted to push these changes from our local repository to a remote repository using the Git provider of our choice. Emulate 3D is completely agnostic. You could push this to GitHub or GitLab or whatever you prefer to use. And this means that a group of people can collaborate and work on the same model and see exactly who made what changes and when. This collaborative workflow is especially useful for catalog development. And when you combine that with the new test runner functionality for unit testing, then you've got a method to make sure that your contribution to a shared project isn't going to break a feature which one of your colleagues have created. We'll look at that in detail in our next feature spotlight video.